Alright, now let's just look into this particular question and see what is actually asked in this question. So if we look closely in the first part, it says that find the x coordinate of the point A and x coordinate of the point C, right? So we are actually interested in finding out these particular x coordinates, right? Now the way we can do that is we can see that this is an overlapping function, like g of x is staying at the top and f of x is staying at the bottom, whereas if you look and below the x-axis the trend is reversed, right? Like g of x is staying at the bottom and f of x is staying at the top. But the way we can find that out is we know that f of x is equal to what? That is equal to cosine of the x, and g of x is equal to the sine of 2x, right? Now what we can do from here is we can make sure, because it's the intersection that we are actually finding out, so this means that we'll put our function equal to each other. So we'll put f of x equals to g of x and we'll try to find out the x value from here, right? So if we do this thing, it becomes cos of x is equal to sine 2x, and if I expand sine 2x, so this can be written as 2 sine x cosine of x because of the double angle identity, and this is given as cos x, right? Now I move all the variables on the one side and I'll put all of that equal to 0. So I end up getting cos of x. I can take that as common and I'm left with 1 minus 2 sine of x, and all of that is equal to 0. Right now we know this property that if the product of two numbers is 0, so this means either one of them is 0, so cos of x is 0, or 1 minus 2 sine of x is equal to 0, right? Now what I'll do is I'll try to find out the value of the x from these particular points. So this is given as cos inverse of 0, and if I rearrange all of this equation, so I end up getting 2 sine of x is equal to 1, where x is equal to sine inverse of 1/2, right? Now what I will do is I will find out the value for x is equal to cos inverse of 0. So we know that when we do the cos inverse of 0, that is equal to 90 degree, or because the value is in radians, so I'll write that as pi over 2, right? Now see, when do we get to know that we need to write our angle in radians or in degrees? So this is the area from where you will actually look into this particular angle. So the domain is given to us is in the radian, so we will be writing our angle in radian as well. Okay, so x is equal to pi over 2, and if we, because when we found that out, so it's between 0 and pi, so this is the only value that I'll get from this equation. Whereas if I look into this particular half, this is given as x is equal to pi over 6. So now we need to look into the quadrants where sine is actually positive. So sine is positive in the first and the second quadrant, so that's pi over 6. So if I want to find out the second angle in the second quadrant, so I can find out that out as pi minus pi over 6, and that is equal to the angle theta. So yeah, I'll utilize the second angle as pi minus pi over 6. So I end up getting 5 pi divided by 6, so that is my x value. Now if I combine all these angles, so I have the x value as pi over 6 because that's the smallest of the angle, that's 30 degree, and that is pi over 2 which is the 90 degree, and then I have the last angle which is given as 5 pi by 6. Now if I want to see that what is 5 pi by 6, so it's 5 into 180 divided by 6, which is equal to 150 degrees. So because all of these angles lie in the within the domain, so yeah, this is going to be the answer. Now if we look into the value of x coordinate of a, so that is given as x coordinate of a is given as pi over 6, and the x coordinate of c is going to be the 5 pi by 6, and the x coordinate of b is actually equal to a pi over 2. Alright, so yeah, these are the three x intercepts or the coordinates that I am looking forward to. By the way, it's already given to us, the point B. So anyways, we have actually shown it through the question as well, that we know how to calculate that, right? Okay, now let's just focus on the part B of it and see how can we find that out. So the shaded region R is enclosed by the graph of F and the graph of G between the points B and C. Find the area of the R, right? Now the way we can find that out is we need to look into the which of the function is staying at the top and which one of them is staying at the bottom, right? So if I go by that analogy, so my function, which is f of x, if I go below the x-axis, so this is the one that is staying at the top, and my function, when I go below the x-axis, so g of x is staying at the bottom, right? So if I look into this thing, if I want to find out the region shaded, so the way I can do that is I need to subtract g of x from the f of x. Like if I do this thing, so I will eventually get the shaded area, right? Like if I want to find out this particular region, so I'll put f of x at the top and then I'll subtract that from g of x, whereas the limit that I'll be substituting in is going to be b and c, right? So if I substitute the limit as b, the x values, because at b point is pi over 2 and at c it was 5 pi over 6. So when I integrate that, I will eventually get the area. Now we have half the job done. We just now need to look into the formula and substitute the values. So f of x over here is given as the cos of x. So we have cos x minus sine 2x, which corresponds to the g of x, and then obviously dx, and then I'll just put the limits over here and then I'll continue with this one. Now when I'm going to integrate that, so this becomes integration of cos x dx and then minus sine 2x dx integration, and it goes from pi on 2 to the 5 pi by 6, and similarly the integral limits actually going to stay the same, right? So yeah, that's the area. Now when I integrate cos of x, so the integration of cos of x is given as sine x, and obviously the limit are pi by 2 and 5 pi over 6. Similarly, if I look up here, it becomes cos 2x divided by a negative 2, because the integration of sine x is negative cosine x, but there is an angle as well which is 2x, so I'll differentiate that and I'll put that in the denominator. So I have pi over 2 and it goes until 5 pi by a 6, right? So now I'll just substitute the values inside this angle. So this becomes 5 pi by 6 minus sine of the angle pi over 2, and then I'll do the negative sign. So this becomes cos 2 times of 5 pi by 6 and divided by a negative 2, and then there is a minus sign, and because there is a minus with the 2 as well, I'll keep that right now, the negative sign, right? So in the very next step I can remove that. So I'll keep the negative sign up here, and when I substitute that, so what I will end up getting is I'll end up getting cos of 2 into 5 pi by 6 and yeah, that is what I'll be inputting inside. So at the end I end up getting cos of 5 pi by 6. Now guys, if you have issues while remembering this thing, like how to look into the angle, so remember what is 5 pi by 6, because it's a paper 1 question, so we need to look into that. It's 5 into 180 divided by a 6, so it becomes 30. So 30 times of 5, it's 150. Now I just need to write that as an 180 degree. So I have sine of 180 minus a 30. So what is that equal to? This can be written as a sine of a 30 degree. Now just focus on the sine of the, like, is it positive or negative in the second quadrant? So sine is always positive, so this is going to be plus sine 30. So this means that sine of 150 degree is exactly equal to the sine of 30 degree. So if I go by that, sine of 30 degree is a 1/2, right? And what is sine of 90 degree? So we all know that what is the value of sine 90? It's actually a 1. And similarly, if I want to find this out, it is going to be cos of 5 pi by 3. So now I will be multiplying that, and it becomes 5 into 180 divided by a 3, which is equal to cos 300. Now what I'll do is I will write cos 300 as the cos 360 minus a 60 degree, right? Now this can be written as a cos 60 degree. Now what is the, because 360 minus 60 lies in the fourth quadrant, so what is the sign of the cosine? What is the, is it positive or negative in the fourth quadrant? So cosine is positive in the fourth quadrant, so I'll assume cos 60. So this means cos 60 will have the exact same value as cos 300, right? So I end up getting a 1/2 in the numerator and -2 stays in the denominator. And similarly, I have the exact same value for the, no, it's gonna be not 5 pi by 6, sorry, I just inputted that slightly, I need to change that, so it's not 5 pi by 6. For the second one, it's going to be the pi over 2, right? So in the second one, I'll just be calculating the value of pi over 2. So we know that cos pi over 2, but still because we have the value with us, pi, so it will cancel out and we are left with cos 180, right? So cos 180 is -1 and divided by a -2. So yeah, this is what we get at the end, because this 2 will get cancelled out with the 2, right? And at the end I'm left with this value, which is given as, let me subtract them. So I have -1/2 minus, so this becomes -1/4, and then I have -1/2. So when I add them together, I'm left with, these two would get cancelled out, and the very obvious reason is because there is a negative outside, so this negative will make it positive and it will get cancelled out with this 1/2, and at the end I'm left with the answer, which is 1/4. So this means that the area enclosed by this region R is given as 1/4, right? So at the end I'll write area R is equal to 1/4, and that's my answer. Thank you.